Hey guys, and welcome back. Today we are talking about covalent compounds and covalent bonds. So far we've talked about ionic bonds. We know that those exist between a metal and a nonmetal. And today we're going to talk about the type of bonds that occur between two or more nonmetals. So today we're focusing on those elements on the right-hand side of the table, those nonmetals. So let's go ahead and jump right in. So first, let's define a covalent compound. A covalent bond is formed when two nonmetals share electrons in order to reach a full octet in their valence shells. So the same concept. The reason that these elements are bonding in the first place is because they want to be stable and they want to be happy. Now, in order to do that, they're trying to fulfill that octet rule. They're trying to fill those 8 valence electrons in their outermost shell. Now, in an ionic bond, the metals were transferring their electrons to the nonmetals. It was a transfer of electrons. Here, the covalent electrons are going to share their electrons, or I should say covalent compounds are going to share their electrons. So co means together. So these elements are going to be sharing their electrons, okay? An example here is going to be water. So there's 2 hydrogen molecules, 1 oxygen atom, and they will share their electrons so that they can all be happy and have that fulfilled octet. Remember, with hydrogen and helium, because they are the first 2 elements on the periodic table, hydrogen only needs 1 additional electron because his octet rule technically doesn't apply because he only has 1 energy level, so he only needs 2 electrons to be happy. So hydrogen needs 1 electron, while oxygen needs 2. They share the unpaired electrons, and each atom gets to fulfill that outermost energy shell, and then they are happy and content. So with our covalent compounds, again, our nonmetals, some of these elements are going to be diatomic. Okay, so they're diatomic molecules. They will covalently bond to themselves to form molecules composed of 2 atoms. So that's what diatomic means. These elements are never found in nature as single atoms. Instead, they'll be bonded as a pair when they are in the elemental state. And these different elements are right here. So they're in yellow and then they're on the bottom. So hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, and fluorine. Now, what does this mean? For now, you just need to know that they exist bonded to each other, right? So if there's hydrogen existing in the elemental state, that means there will always be at least 2 atoms of hydrogen. In the future, when we start balancing chemical reactions, so in our next unit, we are going to have to remember these because when we start balancing and everything, we need to remember that these elements will always have at least 2. But for now, what we need to know is that these nonmetals, they form covalent bonds with each other, and you always find 2 of them together. So there are 7 of them. So the gases, and then all of the halogens as well. So the halogens, remember in group 17, also known as 7A, and then hydrogen, oxygen, and nitrogen. Okay. And of course, hydrogen, oxygen, nitrogen, those exist as gases. So what are some properties of covalent compounds? They bond in different ratios, and they can share multiple electrons between atoms. Now, what we mean by different ratios, remember with our ionic compounds, we determine the ratios based on the charges of the metals and the nonmetal anions. But now we're looking at covalent compounds, and their ratios can be different based on the molecules. They typically have low melting points and low boiling points. They have low enthalpies of fusion and vaporization. We don't have to worry about that right now. They're typically soft or brittle solids. They're good insulators, and they are poor electrical and thermal conductors. And that makes sense, right? Because we're dealing with non-metals. You guys already know this information because we talked about it when we talked about metals versus non-metals. So it makes sense that if covalent compounds only form between non-metals, they would be poor conductors of electricity, soft and brittle, because there aren't any metals in covalent compounds. So we have looked at Lewis dot structures before, but we can look at them to help us determine the types of covalent bonds that are forming between these nonmetals. So they help us determine the types of bonds as well as the shape of the individual molecules. So shared electrons are called bonded pairs, right? So like a bonded pair would be right here between this hydrogen and this fluorine molecule. They are sharing these electrons, and that's a bonded pair. They're placed between the atoms, and lone pairs are on the outside of the atom that are non-bonding. So bonded pairs exist between two separate atoms, and then the lone pairs are on the non-bonding electrons, so on the individual atoms. So here we would have this bonded pair between the hydrogen and the fluorine, and then all of these electrons outside the fluorine, these would be lone pairs. Now, these can show us multiple bonds that exist between our non-metal elements. So sometimes atoms will share more than one electron with another atom. It's possible to share more than one. The more electrons that are shared between atoms, the harder it is to break the bond. So the more bonds, the harder it is to break, which makes sense, right? If you strengthen something, you add some reinforcement, the more bonds you have, the harder it's going to be to break those bonds. Single bonds share 2 electrons, and that would look something like this. Double bonds share 4 electrons, so it's just basically 2 shared pairs of electrons. And then triple bonds would share 6 electrons, and it would look something like this. So single bond, you have to have at least 2 electrons in a bond. So one bond is 2 electrons. So it makes sense that a single bond would be 2, a double bond would be 4, and a triple bond would be 6. And of course, that triple bond is going to be a lot harder to break than that single bond. Okay. Now, when we're writing these, we can use different symbolism to show the different bonds. So here we have these electrons looking at circles right now, but anywhere that we have a bonded pair, it can be replaced with lines. And again, this is in a Lewis dot structure. So if you're looking at a Lewis dot structure and you notice lines instead of these pairs of electrons, that's just going to be an indication that there is a bonded pair. There are 2 electrons that are being shared between 2 atoms. So in this fluorine compound, we have 1 bonded pair. Here we have, so this would be a single bond. A double bond would be represented by 2 lines. And then a triple bond would be represented by 3. Okay. Now, when you're doing Lewis dot structures, or you're looking at a Lewis dot structure where we have bonded pairs represented by these lines, anywhere you see like still the circles, so the electrons, those are just going to be the unpaired electrons that are still around their respective atoms. And that's it. So for today, the biggest takeaways for covalent compounds, because we'll talk about naming tomorrow. We'll do the naming in a separate lesson. You need to know that covalent compounds are between 2 nonmetals, right? It is a sharing of electrons, and you can have single, double, and triple bonds between those covalently bonded compounds. And of course, if we're looking at Lewis dot structures, those bonded pairs are going to be represented by a single line. That's it for this lesson. Like I said, we'll learn how to name covalent compounds in our next lesson, but for now, you guys are good to move on to your graded work for the day.